Zoom recording, and I will admit everyone, okay?
Okay, perfect, thanks.
And I'll let you do the talk initially. And as you can see, you have a few guys from Brazil as well. Yeah.
Perfect. We're happy to have them. I'll go ahead and wait till the top of the hour here, though.
Okay. So I have pretty much 1 hour, 45 minutes.
You can take the full hour.
Okay. Probably take 15 minutes if I'm on time. And then we have 10 minutes for questions.
That would be perfect.
Do you know if others on the other participants can start their video and audio just to make sure that I won't have any interruptions during the presentation? Do you know?
They should come in as muted and with their cameras off.
Okay, but they can start.
I believe that they have the option to start.
Okay.
So I'll keep an eye on things, and if anyone joins and or if they unmute, then I'll go ahead and mute their microphone if it's causing problems.
Okay, cool.
All right, it looks like we have reached the top of the hour, so I'll go ahead and kick things off. Thank you, everybody, for joining our webinar today on Oracle partitioning for DBAs and developers, why, when, and how to use it. Brought to us today by Frankie Faust. I'll go ahead and give Frankie a quick introduction. He works for Pythian as a senior Oracle database consultant and has extensive knowledge with Oracle Exadata and high availability technologies, and with other databases like Snowflake DB, MySQL, Cassandra, and SQL Server. He's always improving his skills, focusing on researching Oracle performance and high availability, and has been involved in some major implementations of multi-node rack in AIX, Linux, Exadata, and multi-site data guard environments. He's certified in OCP 12c, OCE SQL, OCA 11g, OCS Linux 6, and RAC 12c, and was nominated for Oracle ACE in 2017. Frankie is well known in the Brazilian community, and I see he's brought some of his friends along with him today. He has a blog, and I'll go ahead and let him introduce that as well. He's a major contributor to the Oracle Brazilian community. He's also a frequent writer for OTN and a speaker at some Oracle database conferences around the world. So feel free to contact him on social media. With that, I will turn it over to Frankie. Thank you, Frankie.
Thank you, Sean, for the nice introduction. And thank you for having me here. So it's very nice to be part of the UTOUG webinars. I guess I'll have some hard time admitting everyone here while I present. Sean, I don't know. I think people are still joining and they are asked to be admitted. Actually, I'm getting prompt for them to be admitted here.
Oh, are they? Okay.
Yeah, I
See
will
if I
try to keep admitting them while I present, but hopefully that won't distract me too much. Okay, so well, after the nice introduction, I don't think I have more to say about myself. So we are here to talk about Oracle partitioning for DBAs and developers. So we are gonna see why to do it, when and how to do it. So the idea is just to have a brief introduction and explore some cases. So, well, I'll skip this part because Sean already gave a nice introduction about myself. And yeah, that's it. So here you have my social media, email, blog, and ACE profile. In case you want to get in touch, you can screenshot this and save it for later. You can send me email with doubts and anything like that. You can follow me on Twitter, LinkedIn, and feel free to join and speak about partitioning or any other topic that you would like to. So if I can help you, just let me know. And as you know, I'm part of the Oracle ACE program. So if you want to know more about the program itself, feel free to reach out. I work for Python, so just a brief introduction about the company. Since I'm doing this presentation on my working hours. So we are more than 20 years in business. Actually, Python started in 1997. We have more than 400 experts spread around the world, again, more exactly in 35 countries, and we have more than 350 clients globally. And why I decided to make this presentation initially, why I built this up, and why I think this is a good topic to present nowadays, since partitioning is a feature that's pretty mature and pretty old, that was introduced back in Oracle 8. So that's more than 20 years ago. So I decided to do this presentation because I've worked on many different environments with many different customers, with many different sizes, and mainly the big ones, the large databases that I've worked with, they were suffering with many different aspects of how their data is stored and modeled. So I decided to do this presentation because partitioning was one of the main bad contributors for these bad implementations I've seen throughout my career. So, well, I don't consider myself an expert on this topic, but what I've seen and what I've done, I think can probably help you to maybe do a little bit better on your environment. So hopefully I can give you some input on things that you can look at on your environment and how to do it properly. Okay, going ahead. So we have this agenda for today. So we're gonna see quickly about the partitioning concept, what we consider to start building our partition in our databases. We're gonna see quickly a background of the partitioning feature in the Oracle database, and then we're gonna explore the benefits, some implementation scenarios, types of partitioning, and then we will discuss basically 4 types of partitioning, because, well, partitioning is a huge topic. It's pretty extensive, and there is no way I can cover everything under an hour. So we're going to see range, list, interval, and hash partitioning, which are the most common ones, and probably the ones that you will be using on a daily basis. And at last, but not least, we will see some execution plans and how partitioning can benefit the performance of your queries. That's the idea. So getting started with the concepts. So what is partitioning? Partitioning is pretty much breaking down a table or an index into smaller pieces. So when you have a table that's not partitioned, that's a self-contained segment. All your rows, all your data is within a segment that's formed by blocks and extents that's stored in data files and table spaces. So when you partition your table or your indexes, it means that you are creating smaller pieces. These smaller pieces are your segments, and the table or the index itself, they become kind of a view of your partitions. The partition itself will become the segment, and on top of that you have the table, which will host, which will, yeah, pretty much store the metadata to access these partition. And that's in Oracle, that's totally transparent to applications. So you don't need to change your application, you don't need to change your query to query a table that's partitioning. You just need to rely on the partition key. And that's the main focus when you are building your partition, on when you are start planning to implement partitioning. So a partition key, what is a partition key? So the partition key is made of one or a set of columns. So it can be just one column or up to 16 columns. And unique values, they are not required. So it's not like the primary key. So what will be your partition key? Well, that's up to you to decide, and based on the data that you have. Databases like Cassandra, which is a NoSQL database, that database, Cassandra, it totally relies on partition keys. Every table in Cassandra has a partition key. I know the focus here is Oracle, but just to give you an example, for every Cassandra query that you want to execute, you must have a separate table for it, because the table is made of the partition key, and the partition key is actually based on your where clause. So if you have a different where clause, you should have a different partition key. In Cassandra, that's the reality. In Oracle, we don't do that way normally. Sometimes we can create a materialized view that have a different partition key. So we have just a partitioned table with the defined, let's say, partition key based on a range of values on a date column. And we can create, let's say, a materialized view on top of that partitioned table with range partitioning to be partitioned on a column that's, let's say, it's a type, like, or I don't know, a color, something like that, where you can define another partitioning scheme, which would be, let's say, a list partitioning. So we can have different mixes here. And so that's very, very important that you partition your data, your tables, based on the queries that you run against them. So if you have a large table and you have, let's say, a terabyte table, and you have data since the beginning of your company, and you have data back to the 90s, so you probably want to have a very old partitioning with the data from, let's say, 1990 up to 2000. And then for every year since then, you have one partition per year up to 2020, when you start partitioning your data by month, because these are more recent data and you want to query, let's say, the last month, the last quarter, or something like that. So it will be based on the queries that you execute. Does it make sense to have a very large table, tens of terabytes table, and have all these data within one segment only? So partitioning this table will make your life much easier, and probably will make your queries faster. Probably. It doesn't mean that it will be faster. Sometimes it's not. So as I mentioned, every partition is a new segment that is created. Tables that can be partitioned are heap tables and index organized tables. Indexes can also be partitioned, and we have two types of partitioned indexes. They are local and global indexes. Materialized views can be partitioned, also clusters. And we normally want to achieve better performance with when we implement partitioning. That's not always the case, as already mentioned. And what happens when you have better performance is that the post-based optimizer in Oracle is aware of the partitions that you have in the database, and it performs a partition pruning operation where it scans only the partition that matters to satisfy your query. Let me just see how I turn on the pointer. Second. It should be a laser point here. I think. I don't know. What point? Oh, here. Okay. So here you see an example of. Oops. Sorry about that. Of a non-partitioned table, which has data from January to March. And this table, as I mentioned already, is not partitioned, but you have two types of indexes here. You have a partitioned indexes, which let's say 3 segments, 1 indexes per month, which I mean 1 index, but 1 segment per month, 1 partition per month on this index. And you have another one which we call a global index. So we have the index that stores the data for all the months in it. And here we have a partitioned table, which has the same data from January to March. And we have both the same indexes. We have non-partitioned indexes and a global index. Sorry, we have a partitioned index and a non-partitioned index, which is a global index. Some background of partitioning in Oracle. So as I mentioned when I was introducing the topic, partitioning in Oracle was released back in Oracle 8, and that's 1997. So it's more than 20 years old. And it started with range partitioning and global range indexes. And there was a static partition pruning that you could make at that time, and basic maintenance operations where you could add, drop, and exchange partition. And that improved a lot along the years. So Oracle since then, to every release of the Oracle database since then, introduced new features for the Oracle partitioning option. Oracle partitioning in Oracle requires extra licensing. So it's an extra license on top of the Oracle Enterprise Edition. So it's not available for Oracle Standard Edition. You can do partitioning in Standard Edition using the old Postgres approach, I would say, which is using manual partitioning using views. So you create a view on top of all your tables, which will be your segments partitioned by, let's say, by date. And based on that table, you can run your queries. So that's manual, that's painful, but that works if you really need it. And there are new features every new release. And more recently, in Oracle 12c release 2, Oracle introduced, I would say, very good features, which are the online move operations for the tables, and that allowed also all the maintenance partitioning operations to be online. So since 12c release 2, we are able to perform all the partitioning operations in an online way. And that's kind of online for large and high transactional OLTP systems. But that's a topic for another discussion. 19C introduced a new feature that's really cool, which is it's called hybrid partitioning, where we can have data stored in Hive, HDFS, or external files, let's say in Oracle Cloud bucket, not only Oracle, but S3 bucket and things like that. So, and object store bucket there. Yeah, that's pretty much what was introduced in 19C. So why do we care about partitioning? What are the benefits we get from partitioning our tables? So it increased availability of data. How it does that? So let's say you have very old data on your in your OLTP database that you don't query anymore on a daily basis. You just leave it there, and you store that in a very old storage server that you don't care much about its availability and persistence, let's say. So when you partition this data, let's say you have the data from 90s to 2000, you store this in a separate table space that's stored in a separate disk group that's created from the disks that are in this old storage server, or we cannot say always old, but Oracle Exadata X8 was introduced with a new storage server, which is a lower cost storage server that's called extended storage server. And that storage only has physical disks. It doesn't have, it only has hard disk. It doesn't have like NVMe flash storage. So it's really cheap considering the Exadata storage servers. And it also does not have smart scan capability. So in this case, you can probably put your old data, old partitions in this separate disk group that's stored in this cheap storage server. And it increases availability. Why? Because if this storage goes down, only part of your data will go down. And that's data that you don't access anymore that frequently. And you can also compress that data. So you can have more data stored in the storage because you can compress it and you can leverage the lower cost of it. It eases the administration of large segments. So let's say you want to perform a maintenance of a very large table. If your table has 1 terabyte, you need to move 1 terabyte at once. Or if you want to rebuild an index, if it's a 1 terabyte index, you need to rebuild 1 terabyte segment. So that will take a lot of time. It will probably, it won't probably be an online operation, because when you specify that you want to rebuild an index online, Oracle in the background actually creates another segment. It's like a materialized view with the materialized view log. And then the current data of the time that you created or you issued your rebuild index online statement will be taken, and then all the data will be moved. And while the data is being moved to the new segment, there is, let's say, a log in the background that will receive all the recent changes that are being performed to this segment. So at the end of the operation, the index will require an exclusive lock to this table to be able to merge all the new data that was inserted or changed in this table while you were rebuilding the index. So for a 1 terabyte table, it can take a lot of time of unavailability. So that exclusive lock can take time. And that's not actually online, even if you specify it online on your rebuild operation. So yeah, it's not always online as we read on the statement. It can be online if your segments are smaller. So if you have smaller indexes, because your table is partitioned and also your indexes are partitioned, you can have smaller, let's say smaller maintenance windows, because the rebuild will be faster for each segment. So it's easier to manage your database that way using partitioning. It might improve the performance of some queries. And pay attention here, it might improve. It doesn't mean it will improve. So it might improve the performance of some queries, and it probably will reduce the performance of some other queries. Because as I mentioned, you have to create your partitioning scheme based on the partition key that will satisfy your queries, mostly your where clause. So you have many different where clauses for every table of your database, and that's something that you cannot achieve easily. You cannot match all, probably you cannot match all your where clauses with only one partitioning key, and that's the case that I mentioned about using probably materialized views for that. It might reduce contention on hot OLTP segments. So there is a type of partitioning that we will see that can reduce buffer busy weights on these high concurrent OLTP segments. So when do we do that? When do we implement partitioning? So when we have large volume of data and administration becomes difficult. So what is large data? What is a very large database, a VLDB? There is no single number to define it. So we cannot say, well, 1 terabyte is a very large database. For nowadays servers, it's not. Probably it's not. But if you have like a laptop running a 1 terabyte database, probably it's very large for this laptop to run it. So it depends on the size of your servers, the memory capacity you have, the IO transfer speed that you have on your storages. We can say that when administration of this database becomes difficult, it's probably a very large database for you to administer. And that start making sense to start implementing partitioning. When query performance suffers on large tables. So if you're running a query to, let's say, aggregate some data in a column or something like that, so you instead of querying just a portion of the table with a few amount of rows, let's say dozens or hundreds of rows, you are querying the whole month instead of one day or a few minutes of your data that's being ingested. So you see, we're mostly talking about data warehouse environments where we have basically reports running, our BI tools, building dashboard and things like that. So partitioning applies very well to data warehouse environments. So when you have these large tables where you are scanning quarter for the sales period, and that's a lot of data for an index to suffice your query. So probably the Oracle optimizer won't use this index because it's too much data to be used on from an index. So it will cost more to the optimizer to choose an access path using an index instead of scanning the whole table. So it decides to go with table access full. And when we have partitioning and you want only 3 months of data and you partition your table based on the month, you will have only to scan 3 partitions. So instead of scanning 20 years of data, you query 3 months of data and you get no indexes, or maybe you get indexes if you have indexes, local indexes on top of these partitions. Maybe the optimizer can use the index, maybe not, depends on your query and your filters, but it will be much faster on these large table scans. Buffer busy weights. When you have buffer busy weights in high concurrent tables, you can use one type of partitioning to try to eliminate this contention, because one of the partitions can spread the data blocks across, it can spread evenly the data blocks across all the partitions you have in place. So that will reduce the contention you probably have on insert operations, massive insert operations. And that's really massive insert operations based on sequences, because the blocks are inserted on a sequence way, and they go to the same block. So you have different sessions trying to insert the same not the same rows, but trying to insert rows into the same blocks, because they use sequence numbers. So 1, 2, 3, 4, 5, 8 goes to block 1, and rows 9 to 16 goes to block 2, and things like that. So when you have these kind of scenarios, you can start seeing, you probably start seeing buffer busy waits and queue index contention. And if you see that, hash partitioning is your friend. Probably it's your friend to reduce buffer busy waits. Doesn't mean it won't cause you more trouble and more pain on the query. So that's a situation you need to analyze very carefully. We can achieve horizontal scalability in rack using partitioning. That's pretty rare case, but you can use it to scale your applications in a real application clusters database. Let's say you have client A. Let's say your table is partitioned by client, and you have many clients on this, or you have, let's say, 4 clients on this table. So you have data from 4 different clients. You have a 4-node cluster. For client A, you can query the data from node 1. From client B, you can query the data from node 2. And that won't cause you trouble, because the data will not be transferred through the real application cluster's interconnect network, and that will probably make your scalability more horizontal. We know that sales pitch for rack is that it's scalable. It is scalable, but it's not very easy to achieve that, and partitioning can help on that. But bear in mind that you probably need to change your application a little bit, or maybe at least change the connection string, your services to, or maybe part of your, let's say, client A connection string, TNS names will connect to service A, which runs on node 1. Client B connects to service B in your cluster, which runs in node 2. So that way you can achieve the scalability I'm talking about. You can decrease your storage costs. I already mentioned a scenario where you can have extended storage server in an Exadata environment, where you can store your old data there. And partitioning is frequently used when you want to have compression and row archival of your current database. So you have an OLTP database, which is pretty large, and you don't want to, let's say, archive the data off this OLTP database. You can simply partition the data, compress it, and archive it in a lower cost storage, and have it online for when your queries want to scan them. So yeah, it's really nice, works really well. Here we have a simple example of an Exadata environment, which is I got this image from one of the Oracle documents. Here we can say we have 100 terabytes of user data. If you apply HCC, hybrid columnar compression, where you have which you have in Exadata or any other Oracle storage solution, you can get let's say 10 times compression. So instead of being 100 terabyte, it turns to be 10 terabyte of user data. With partitioning, you can partition your data, and when you run your query, instead of querying 10 terabytes of data, you query only 2 terabytes. From these 2 terabytes, you could have 1 terabyte on disk and 1 terabyte in memory for your online aggregations, let's say. And using the storage index capability that you have in Exadata, instead of querying or returning 2 terabytes of data that you scan in the storage server, the data that's actually returned to the user is only 100 gigabytes based on the where clause that you specify. So predicate filtering occurs, and smarts can leverage that and takes only 100, only actually, sorry, that's a storage index. So storage indexes maps the data and prunes the data that's not needed. And when SmartScan gets into action, it sees that the user is only requesting a portion of the rows and a portion of the columns. So instead of returning all the columns and all the rows back to the user, it returns only 30 gigabytes of data. So on top of the 100 terabytes of data that we would normally have scanned in a normal non-Exadata environment, you would only return 30 gigabytes. Obviously, that's just one scenario, but that's real. That happens not on a daily basis, but we see scenarios of this. And I'm not from Oracle. I'm not selling anything here. And you don't need any index to help on this operation. That's really true. Next month, if Sean allows me, I will speak about Smart Scan on Oracle Exadata, and we will see some scenarios using one case with Smart Scan, so you can see the power of it and storage index and things like that. So back to partitioning. So types of partitioning. How do we partition our data? So I already mentioned that we have range partitioning, hash partitioning, list, interval reference partitioning, virtual column-based partitioning, and in 19C we have hybrid partitioning. So what are those? What they are used for? Range partitioning, it's used for, it's better to be used for dates and numbers. So dates and numbers are good candidates. Let's say you have a delivery date column on your application, on your table, or you have your primary key, which is a number. You can partition your table based on the primary key ID column. Remember that the partition key can be any column of your table. It can also be your primary key. Doesn't need to be, but it can be if you query your data based on the ID column of your primary key or on the primary key columns that you have. Range partitioning, they are based on the upper boundary limit. Upper boundary limit, that's pretty redundant. So on the upper boundary of your data. So let's say you want to create partition. You want to partition your tables by month. So let's say you want a partition for the month of April. When you're going to create your partition, you need to specify that you want all the values less than the 1st of May to go to this partition. So everything that's less than the 1st of May will go to the April partition. And before April, you have one for March, right? So if you want all the data from March to go to the March partition, when you create the March partition, you need to specify that you want all the data that's less than the 1st of April. So it's based on the upper boundary. We're gonna see some examples soon. Hash partitioning, that's used normally for high volume OLTP segments or when you are lazy. Because with hash partitioning, we can just define how many partitions we want. So let's say I want 64 partitions for this table, and I don't want to bother about how I will partition it. So the data will be evenly spread across all these 64 partitions. So it's normally used for high volume OLTP segments because, as I mentioned, when we have like these buffer busy weights and enqueue index contention, hash partitioning spreads the data evenly and randomly across all the partitions that we have created. So for every insert statement, it means that even if it's sequenced insert operation, every row will go to a different partition. It will spread the data. That's good for DML. for insert, actually, not for all the ML operations. Data, I already mentioned that, data is evenly distributed across partitions. List partitioning, we have normally categories, colors, ports, brands, type, and these kind of columns. So when we can create a list, and that doesn't mean that that all the data will be evenly spread across partitions, because you can have, like, let's say uh, some colors that could be together. Let's say the warm colors, red, orange, yellow, they can be in one partition, while blue, green, and I don't know, white can be in another partition. But you have another partition that's the default one for all the other columns that you didn't specify. So probably the default partition will be larger than the others, because all the other columns will go there. So need to take that into consideration. We have interval partition, which is the automated range partitioning. It will be created automatically. You don't need to bother about creating every partition ahead of time. So interval partition automates that, and that was introduced back in Oracle 11. So that's pretty mature nowadays in 19C. Reference partitioning, which we will not see because we don't have time and I'm already late. That's pretty much the relational, that takes into consideration pretty much the relational model between primary key and foreign keys. And that's normally also called equipartitioning, because that's when we have equijoins. Interval reference partitioning, which is the same as reference, but with interval automated partitions. Virtual column-based partition based on virtual columns. And on 19C, we have hybrid partition, which are actually external partitions, where you can have, let's say, an external file stored outside the let's say the disk group that you have. So that could be sitting in a NFS file system, and you access that using this hybrid partitioning capability that was introduced in 19C. So range partitioning, how do we do that? Here I have my table sales. I just renamed it to sales part to just to mean that it's my partitioned table, but you don't need to rename your tables. It will be totally transparent to your application. So it could be sales instead of sales part. So for my test here, my partitioning key here is the column order date, and I'm partitioning this column by range. So all the data that's before 2017 is going to this partition before 2017. And that takes data that's less than January 1st of 2017. So data up to December 2016, which is before 2017, will go to this partition. And for every new month after that, we have one partition. So for every new month, we are creating ahead of time. Actually, this presentation was made back then. So for every new month, we create new partitions per month. And we have here the data distribution. So for before 2017, we have 19,000 rows. And pretty much for every month, we have between 56 to 62 rows for every month. And for the later ones here, which are May 2018 and June 2018, we have 6 rows for May and 0 rows for June. And we can see that the high value accepted are actually values less than the 1st of July. That's the partition of June 2018. So that's one example. Here I have my table cars, and that's well, that's a cars table. I have ID, I have a car column, model, brand, and price, and I'm partitioning this table by the column brand. So brand is my partition key here, and I'm using a list partitioning scheme. And I'm defining here the partition is the partitions I want. So I have a partition called BMW that will accept values is equal to BMW string, uppercase BMW string. I have a partition for Ford, for Fiat, for Ferrari, for Toyota, for Honda, Kia, Mercedes, Land Rover, Mini, and for the Volkswagen, we have a partition called VW_AG, which is the meaning of Volkswagen Group. So for the Volkswagen brands, we have Audi, Lamborghini, Bugatti, Bentley, Porsche, Seat, and Volkswagen. And all other brands will go to our default partition, which is named all others. So if we have a row that does not match any of the partition values that we specified, it will go to our default partition. And here we have some insert statements. So we have a few insert statements. And we see that for the VW_AG partition, we have 7 rows because but you see that we don't have 7 rows as Volkswagen. We have let's see what is that? Bugatti goes to VW_AG as well. We have well, we have some others that I'm not. Audi goes to VW_AG as well. So you see, we have 5 rows here plus Bugatti and Audi. That makes up 7. We have here an example of hash partitioning. So how do we do hash partitioning? I'm partitioning my cars table by hash, which I'm choosing the brand column to be my partitioning key. We have, I defined it here 7 partitions. So I have partition P1 up to P7. So that makes 7 partitions. And I now insert the same data I had before in the previous example. And we see that we have 7 rows in partition 4 and 0 rows in partition 7. Frank, you mentioned earlier when you were explaining about the types of partitioning that hash partitioning would evenly spread the data across all your partitions. And that's really weird. Dr. House here, it's not getting the point. So I mentioned earlier that it should be evenly spread. So let's try another example. So let's say Oracle doesn't like odd numbers. So let's try with 6 partitions. Okay, 6 partition, an even number. Let's try again. Okay, we have 6 partition, and again, have 7 rows in partition 4 and 1 row in partition 6. Okay, I'm getting tired of this, and you probably too. I try another one. So here I have 8 partitions. So I go back to the documentation. I check the hash partitioning docs and concepts, and I see that there is a statement there in the documentation that hash partitioning should have a power of 2 number of partitions. So 8 is a power of 2. So 8 should be good for hash partitioning. And I'm using the brand column to be my partition key. Okay, so now I expect the data to be evenly distributed, right? Oh, come on, Frankie, again. 6 rows in partition number 4, 0 rows in partition number 7. Okay, guys, what are we doing wrong here? One more example, 8 partitions, but now I changed my partitioning key. Partitioning key here is the ID column. Why ID? Because going back to the documentation, hash partitioning is based on a hash algorithm. Hash algorithm works well with numbers instead of char column like I had for the brand data type, for the brand column. So varchar data type is not good for hash algorithms. So I'm using here a number data type to work better with hash partitioning. Okay, that's not evenly distributed, but it's better. At least we have almost evenly. And when we apply that, because this is a pretty small table, so it's evenly distributed almost. So that makes sense to use with larger implementations, large tables. Here it's a very small one. So use your brain, read the documentation, and use your brain, read it well, fully. So I'm applying the hash partitioning to my sales table, which has more rows. I'm using the ID column to be my partitioning key, and I'm defining here a partition. So using hash partitioning, if I don't want to specify the partition name, I can only specify how many partitions I want. So remember that the number of partition needs to be a power of 2. So 8, 16, 32, 64, 128, up to you, up to what you need. And we apply here, we see pretty much even distribution across all my system generated named partitions. So here we have system generated names because I didn't specify the partitioning name. Okay, Dr. House is fine now. He likes the approach. It's working. So let's just prove that with not power of 2 partitions, we see a discrepancy on the number of rows that are spread across partitions. So we see that partition 4 has almost 5,000 rows, while all the others have 2,500 rows. Oh, works. Interval partitioning, pretty much the same scenario that we have with range partitioning. So I create an initial partition that will store all the data that's before 2017. And everything that comes after that will go to monthly partition that's based on this interval that I'm specifying here. And my partitioning key here is my order date column. So it will since we are relying on Oracle to define the names of our partitions because we're not specifying the names of the partitions here. Oracle will create the partitions based on a system generated name. So it will follow a sequenced number. I mean, it's a sequenced number in my example here, but it probably won't be in your environment, because as you insert the data, you probably have other partition tables, and they will use probably the names before this one uses. So in my example here, I have a sequenced names, and we have position here that where our data is seated for, in which position of the partitions that our data is sit. So here we have the last partition that we have is from data that's less than June 2018. If I insert more rows, so here I'm inserting rows from July 2018 up to February 2019, and Oracle created more partitions, one for each month. And we have the last one being here, the partition that stores data that's less than March 2019, which is the last row here I have is from February. So if I insert a new row from 2021, Oracle will create a new partition here with one row that suffices this query, February 2021. And we have here in position number 7, and the system generated name for the partition is number 36 here. So now you see we have a gap here. We have March 2019, and here we have March 2021, 2 years gap. If I insert a row into that gap, Oracle will create a partition to support that gap. So to support that row that's being inserted, and the gap is reduced. So we have a row here that's from February 2020. And you see that the system generated name is 37. So because this partition was created after the 36, because we inserted the row after, but the position is 27 because that row is from the date of 2020 instead of 2021. So that's how interval partitioning works. And now we'll see some example of the execution plan. So bear with me for a second to understand the data model here and how the data is stored. So we have before 2017, where we have 45,000 rows here. Pretty much all other partitions have about 150 rows. It's one for each month. And we have a Pmax. This is a range partitioning, so that's not an interval. So if I don't want to raise an error on my application, I should have this Pmax partition, which will accept max values that are not matched for any of these other high value statements here. So I create a max value partition, and that has 2,150 rows. So when I start querying my data, so here I have an example of the data that's stored there. So we have order date, that's our partition key, and we have data back to 1992. And here I'm querying data from February 2015 until July 31st of July 2015. That's my execution plan, my plan hash value. We see that the cost for this execution plan is 150, 161. We see that number of blocks that are being scanned are 471. And we see that we have a partition range single operation, and that starts on partition number 1 and stops on partition number 1. And that's for this table, it's table access full, but we see that it's a partition range single on top of that. So that's what the CBO is doing. We see that the estimated rows are 910 and the actual rows are 905. So the estimation is really good. It's pretty accurate, means that our optimizer statistics are up to date and good for this query. So Frankie, if you have one partition per month, why this query is querying only one partition if you are querying data from 2015, February 2015 to July 2015? Well, because we have all the data that's before 2017 only in one partition. So that's why we see this here. It only scans this partition before 2017. Okay, next example. Here we have data from 1 month only. So starting on July 2015, the 1st of July, up to 31st of July 2015. The execution plan didn't change. You see, that's the same plan hash value. That's the same execution plan. Only what changed is the number of rows that are being returned. So here the estimation is 160 rows and the actual rows is 155. We see that the number of buffer gets is the same, even though the actual rows that were returned are less. Why is that? Because this is a partition range single, means that the full partition will be scanned, is being scanned here. And the cost is the same because it's the same amount of blocks that are being returned from this full segment here, which is our first, our piece start and piece stop, our first partition. It's only one partition that's being scanned. Another example, 1 day of data. So 30 of July to 31st of July, we have the same execution plan again. We have the same cost and the same buffer gets. We have just one partition being queried and the estimated rows and actual rows. So estimated rows 15 and actual rows only 10. So again, since it's the same partition, we are scanning the whole partition. And it's the same cost and same number of blocks that are being scanned. Now it changed. Okay, here we have now a different execution plan. Our plan hash value changed. We see that we are querying data from the 1st of February 2017 up to 31st of July 2017. We see that our costs reduced by more than 10 times here. So, and we see the number of buffers, instead of getting 400 and something blocks back from the storage, we are getting back only 36. And we see that the partition range, instead of being partition range single, it's now partition range iterator, where we have a P start partition, initial partition, and final partition. So P start and P stop starts on partition number 3 and stops on partition number 8. And we are scanning 900 910 rows are estimated and 905 rows are getting returned. So that's less because we are scanning less data, because data from 3 months is actually less, it's actually 5 months. So data from 5 months is actually less than all the data that I have in the before 2017 partition. That's how partitioning works. If we're querying only the month of July, check. The execution plan change it back to what we had before. So this is the initial execution plan we had where when we were scanning the before 2017 partition, where we have all the data that's before 2017 year. And now we have it back. So it's the same execution plan, partition range single, where we are scanning now only one partition. So it starts on partition number 8 and it stops on partition number 8. Only 6 buffers are being returned, 6 blocks are being returned. And the cost for this operation is only 3. So we have the same execution plan, but note that the cost is much, much less. So it's costing only 3 for the optimizer instead of costing 161 where we had before, which we had before. If we do the same thing, but only 1 day of data, so from the 30th of July 2017 up to the 31st of July, the same year, we are scanning still the same partition because we are partitioning by month, not by day. So it will be the same number of buffers, but the amount of rows that are being returned are only 10 instead of 155 that we had in the previous example. So that's how partitioning works, and that's why it's awesome. So we get reduction on the cost of the queries. Data is pruned as we go, as we query them. I'm actually a bit late. Sean, is it okay if I continue just to finish the presentation? I have 2 minutes left.
Yeah, go ahead. I think we'll be all right.
Okay, cool. Thanks. So as you probably noticed or not, I've been running all these examples in the Oracle Live SQL. So if you want to reproduce that, you can use, probably I can share the script also if I still have it. I think I have it. So everything was executed and tested in the Oracle Live SQL, livesql.oracle.com, if I'm not mistaken. So here I'm creating an index just to prove to you that an index is not always better when you have partitioned data. So I'm creating an index, gathering stats for these indexes after it's created. So I'm actually gathering the stats for the sales part table and using the option cascade equals to true, which means that it will cascade the gather stats to the indexes, to all the indexes that are part of this table. And here I'm specifying no invalidate equals to false. That means that all the execution plans that will be invalidated. So it will probably make sense to be these invalidate equals to true, but the flag is no invalidate. So no invalidate equals to false will invalidate all your cursors, your execution plans. So after doing that, I'm forcing here a hint index. I'm forcing the use of the index that I just created. So index sales p underscore od. And my where clause is querying data only from 1 day here. It's the 30th of July until 31st of July. This is my new execution plan. And my new plan hash value with this new execution plan where we have a table access by global index row ID batched. So we have the cost of being 17 and we have 6 buffers being returned. We see that we are scanning the sales part starting on partition number 8 and stopping on partition number 8. So this is only 1 day of data and only 10 rows are being returned. I'm forcing the use of the indexes. Why? Because the optimizer was not choosing to use index. That's why I'm forcing it, to show you that's not always the case. When you have an index, even for 1 day of data, it's not always better than to have a partition. So let the CBO decide. Do not use hints that if you're not sure of what you're doing. So hints are not the way to go. Don't try to be smarter than the CBO. There's a lot of math on it. So here we have a cost of 17 and 6 buffers. 10 rows are being returned. Creating another one to be a local index, the same name _L, that's being a local index. So I'm creating a local index instead of a global one, just to test another case, gathering stats for this table again, and also its indexes. The same query, just changing the index. Another execution plan. Instead of table access by global, now I have table access by local index row ID batched. And we have the cost of being 5. Okay, better. We had previously 17 with the global index. Now we have a cost of 5. We used to have 6 buffer gets. Now we have only 5, which is better. And partitions being scanned, starting partition 8, stopping partition 8, the same number of rows being returned. The time will not change. So the time that it took to execute this is under a second, at probably 1 centisecond or something like that. So it won't change too much here, but we see that the cost is less having a local index. Okay, let's try now without an index. How much does it cost for the CBO to query that only 1 day? And bear in mind that we have the data partition by month. So it's the whole month that's being scanned. So with this partition range single, Oracle is scanning all the data. So instead of only 1 day, it's being scanned all the data for the whole month, and it's throwing away, but it's cheaper for the optimizer to do that than using an index. So we see that the number of buffers, it increased a little bit, but the cost is less. And the same, because in this case, we are scanning only one segment. If we use an index, the CBO needs to scan two segments. We have here the index that's being scanned, and also the sales segment, the partition segment for the sales table. So that costs more because of that. And here we have a cost of 3. So the CBO will choose to do this way. You see that it chooses that path because I didn't specify an index here. So not specifying the hint of the index. So it's choosing to go with the partition range single operation and scanning the whole partition. Wow, Dr. House is impressed. And that's it for the execution plan. So hope you guys are enjoying it. We have just this last example, which is one simple example for partitioning maintenance operations. Here we have all the partitions and index and all the data that I have in this schema. So I have this sales schema. We have the sales part, which is actually my table that is partitioned. We see that the partition name for every month, we have the P4 2017 partition. And what we want to do here, we want to merge all the data that's 2017. So all the months of 2017, all the partitions will be merged with the P4 2017 partition. So we are going to merge all these partitions before 2017, all the partitions from 2017 into partition before 2018. So this will go away, also the before 2017, and we will have before 2018 now. And we can do that online since 12C release 2. Probably in 12C release 1 as well, but I'm not sure. But from 12C release 2, I'm sure. So we can do that online. Bear in mind that online operations for large tables, maybe we require a little bit of downtime from the application, not from the database itself. but well, every case is a different case. You probably have, you probably won't have, I don't know, depends. And while this move or actually merge operation is running, you can probably see some odd wait events on your queries that are querying this data, which can be, I think it's NQ, QMV. I don't remember very well, but I think it's NQMV or NQ. I think there are two MS. I don't remember. I can, well, if you want to know, you can send me an email and I'll share with you. I have the details, you know, in a ticket that I've worked on in the past. So I'm merging the partition. So here I have all the partitions from 2017 and the before 2017 partitions are gone. And we have everything merged into this before 2018 partition. So that's probably an operation that you do on a yearly basis. So every year you probably merge all the partitions from the previous years together. That's something that we actually do, and probably it's worth automating that. And you can automate that. There is another option in Oracle database that you can use, which is called information lifecycle management, that you combine with automatic data optimization that can do everything automatically for you. So that's based on some policies that you define, and you don't need to bother about creating scripts to do that and anything. So that's like magic. Happens everything in the background, no bugs. Kidding. Maybe you will face some, but who knows. So yeah, we have a new partition created that has 127 megabytes, very large. And we can, again, perform another maintenance operation. So let's say we want to store these with the compression. So we can alter table, move partition before 2018, row store, compress, advanced, and we can move that to another table space. So that was in the users table space. Now I'm moving the partition to the comp, which is compressed data, comp underscore data table space. And instead of having 127 megabytes, now it has only 80 megabytes. So that's, yeah, 70%, I don't know to calculate, but yeah, that's it, guys. That's all I had, and you can do that online as well from 12c release 2 onwards. Well, that's it. Conclusion very quickly. Range partitioning, hash partitioning, list partitioning, and interval partitioning. We just saw some brief examples. As I mentioned, it's a huge topic. We cannot cover under an hour, and I'm 110 minutes, also 10 minutes over an hour, sorry, 1 hour and 10 minutes, so 10 minutes over an hour. From 12c release 2 onwards, can perform most partitioning operation online. And I think it's all of them. I'm not sure, but I'm pretty much sure. Performance problems in read or write operations can get better or worse. So you can solve problems or you can introduce new problems using partitioning. So you need to plan very, very well and test your queries in your dev and QA environments. And every new release, there are new features. It's been like that for years on the partitioning option for the Oracle database. I hope you liked it. If you have any questions, let me know. I don't think Sean will prevent you to ask anything. So.
Oh, no. If anyone has any questions, feel free to drop them into the chat window.
Thank you very much.
And thank you, Frankie. That was really informative.
Yeah, you're welcome. Pretty quick one. I had to end faster at the end. Any doubts, any question, guys? Anything you want to ask? Let me know. I don't see a chat window. Oh, I see chat now. I don't think anyone has any questions. So everybody's an expert now in partitioning.
Yeah, I don't see any questions in there, but everyone, feel free to reach out to Frankie or to us at UTOUG, and we can forward your questions on to him if anything comes up afterward. Thank you so much, Frankie, for being a part of this and sharing your knowledge with the group. And we look forward to having you again. As Frankie mentioned earlier, we're going to have him here in May to talk about SmartScan toward the end of the month. So keep an eye on the website for the announcement of that webinar. And if there are no questions, then I'm going to go ahead and close things out.
Cool. Thank you, guys. Thank you very much for the opportunity again, and we'll see you next month. I guess that's it. See you guys.
Great. Thanks, everyone.
Bye. I'll stop sharing.